Here's the new version of the BrotherHobby Tornado T2 1608. This one's in 3200 kV and is the second one released in this size. The first one was the 3600 kV version, but this one's T1. So this one's a revision of the original one. So there's a couple of changes that the factory made, which are pretty good. It seems they listen to users as to what they wanted in a motor of this size. So that's pretty cool. Actually, when they were prototyping this motor, they were pretty active on the forums and sending it out to reviewers to find out how the 3600 kV version performed. So it seems they've incorporated a lot of the suggestions into this new version. So hopefully the trust test results will show a lot of improvement with this new revision. So on the outside, they look pretty similar. Actually, the armature looks almost, pretty much identical. There are some changes on the outside that are pretty visible. They went to M3 fasteners for motor mount. This used to be 2 millimeters before, and the shaft was 3 millimeter hollow shaft before, and now they went to a solid shaft. Also, let's see, yeah, they still kept the grub screw there. It was also used before. It's right there. The motor leads are longer now. They provide you. They used to be, let's see, they used to be about 85 millimeters, and now they come with about 250 millimeters. So that's pretty good. They've again, that's one of the changes that were suggested. Now with the 4-in-1 ESCs, all in one FC, ESCs, PDB, everything included, the longer motor leads are a better feature. So let's see what's inside, what the differences are between the old the T1 version and the T2 version. There are also some improvements on the inside, which are more readily visible. So on the original, this was a 9N 12P configuration. So this one had 12 poles and 9 stator tooth. The new version is more like the 2205s, 2204, more like the 22 size motors. This is a 12N 14P configuration, so it's 14 poles and 12 stator teeth. Also pretty visible, a little bit longer here, whereas before it was quite short. So the amount of copper on this new version it's increased. So that alone should give it better efficiency, and perhaps even I think it's going to give it more torque. well, that combined with the lower kV. So this is 3200 kV. This is 3600 kV. So this should be more efficient and probably a better match for what this motor target was intended, which is most likely a 4-inch frame. 4-inch meaning 4-inch blades. So this will have more torque for driving those 4-inch blades. This one could drive them. Before I have the results on this one on the channel. So this one was able to drive it, but to drive a 4-inch blade, no problem. But it was using quite a lot of amps, so it made a lot of thrust. So, but it was using a lot of amps. The other difference is well, you can see here the amount of material here on the stator. All of this wasn't being used, so there's much better utilization of the packaging here, of the space. The bearings seem to be the same. Well, this one's 6x3 and this looks like 6x3, so they're about the same size of bearing. In the back, they're both being held by those circlips. The shaft are retained by circlips, so no change there. And you can see the stators. They seem to be about the same laminations. So, well, now let's look at it on the close-up. So here's more or less a comparison of both stators. Their height is pretty much the same, nominal 8 millimeters on both, so no surprises there. 8 millimeters on the new one, and the T1 version was also 8 millimeters, so that's no change there. The air gap on the new 3200 kV version is it's pretty decent. Not the tightest one I've seen from BrotherHobby, but it's still pretty good. Air gap is the distance between the face of the stator tooth to the face of the magnet. Also, the magnets from on the previous T1 version, they were just slightly curved. They weren't really true arc magnets, but they do have seems that they have like a little roundness to them. The new ones, the new motor, they also don't seem to be curved, but because they're so narrow due to the overall diameter of the rotor part, the motors, this being a 14P configuration, the magnets are narrow, so they don't, it doesn't affect it much, the fact that they're not curved, because they're pretty narrow. So let's see what the difference in weights are on both these versions on the bell. This one, this is the 3600 kV with 12P configuration. This one is a 14P configuration. So let's see, this one has a slightly chunkier magnets. right about 12 grams. So this new one, 11.8, so 0.2 grams difference, not a lot. Now this one has a shorter wire, so this amount of wire is about makes it about the same length of wires as the new version. So I'm gonna include it here so that we're weighing the same amount of wire. Let's see, this one weighs in at 14.1. That's the 3600 kV T1. This is the new version. 11.4. So there's a good difference there in weight on the stator portion. I imagine that's due to this area here. There's a lot of material here on the stator that this one has, as opposed to this one. This one has a lot less material right there. So now let's weigh it together, I guess. So let's see what it weighs, and that, keep in mind, that's with the long 250 millimeter worth of wire. So that's 22.9. So if you make it about 80 or 90 millimeters length of wire, that's about 1.2 grams, the extra wire. So it's about 22 grams altogether. This motor, not too bad. I mean, it weighs about the same as a 2204, as a light 2204. It seems, I mean, you think that it would be lighter, but there's just no way around making it lighter, you know, with the height of the stator being 8 millimeters. That's where most of the weight comes from. When you have a tall stator, there's a lot of weight there on the laminations and the copper. So, but that in turn gives you a lot of torque. So that's the advantage of the tall stator motors. So now on to the thrust test. Let's see how these T2 1608 3200 kV motor, let's see how it performs.
Alright, let's look at the results of the thrust test for the BrotherHobby T2 1608 3200 kV motor. Some pretty high numbers here on 4-inch props, but it looks like we're gonna have to match this motor to a couple of very specific props depending on what you want to do with it. So for light, ultralight 4-inch or 5-inch frames, you're gonna want to probably run on 4S or 3S, and looks like the Dow T4045, DYS 4040x3, and perhaps even the also the Lumineer 4040x3, the GenFan 5030, and perhaps even the 5040 prop are gonna be some of the props that you may want to try with this motor. I didn't run it on 4S with the 5040x3 because it was the amp draw was already getting pretty high on the thrust stand for the 2-blade 5040, so I didn't want to mess up the windings on the motor. Just keep in mind, as I always say, on the thrust stand, these amp draw and thrust is gonna be definitely exaggerated. It's gonna be more than what you actually see in actual use. The load, the amps are gonna be anywhere from 25 to 35% less once you get moving and once you're flying. But on the thrust stand, because I'm using a power supply and the volts almost don't sag at all, and the air is static. It's not recirculating, so it's just there. There's a lot of recirculation and turbulence, so the props have to fight. The motor has to fight even more. It gets stressed, basically, a lot more than when you're in the air. The air is moving through the blade, so there's less air to grab, and it already has the air molecules already have a velocity. So when they encounter the blade, as opposed to the air just being standing air. So that's why we see these very high numbers on the static thrust. So this 5040x3, it could very well be possible to use it in the air, but I'd be careful if you go on 4S with this motor. I just do a quick run and check the temps. But I would think it would work with the 5040x3. Alright, so let's do a quick comparison against the 3600 kV version of this motor. This one I tested a few months ago. I'll put the link to the test at the end of the video. These two are different configurations, as I mentioned on the teardown portion. The 3600 kV is a 9N 12P 12-pole motor, and the 3200 kV is a 12N 14P configuration, so it's 14-pole. The differences are noticeable, but the 3200 kV, as expected, is a bit more efficient. It's still making pretty good thrust. Of course, the 3600 kV makes more thrust, but it's using more amps. So let's look at a couple of the props that I tested on both. The 4045, which is probably not a good match for this motor. The motor is sort of heavy, and this prop is kind of limited. It would be limiting the thrust on the motor, I think. So this prop is better matched with a smaller motor, 17 size, or maybe a 14, actually 13 to 17 size motors. This Gen Fan 4045 matches pretty well, but this motor is probably a little bit too big for that prop. But it still makes some decent thrust on both A45 and 921. Pretty good difference on amperage on these two. You can see it's about 7 amps difference, so that's quite noticeable. The next one that's similar is the same prop is the T4045. This prop has been getting pretty popular with the 1407 crowd. And here we can see 1138 versus 1044. Fairly close. I mean, only about 100-gram difference. So it's like at around 9% or so difference. Yet the amps are much better. The draw, the efficiency is much better on the 3200 kV, of course. Next one that I tested is this HQ5040 5-inch prop. On the 3600 kV, it's just some pretty impressive thrust out of that 5-inch prop. Of course, at a very high amp, so you know, you gotta keep that in mind for this 5-inch prop. On the 3200 kV, the same, you know, it looks like for that much load on the motor, that big prop is making it draw a lot of amps. So it's probably not a good match. You know, you would run through your battery pretty fast. So it looks like the 5030, if you want to go with a 5-inch prop, the 5030 would be a better match. 35 amps here on the static, so in flight it's gonna be a lot less, probably around 27, 25 amps maybe. So that's pretty manageable. So a 5030 would be a better match, or a 5040x3 on 3S. Looks like it would work. So you know, it's this motor is kind of a unique motor. So we gotta see which prop is gonna match well. Looks like the 4-inch prop. 4-inch prop. This T4045x3 prop is gonna be one of the better matches. I didn't run the Team Racecraft 5038 because those props are made for flying forward. So on the static, they don't really show their performance. It doesn't translate well how they perform. They'll show like a very low thrust, but we all know that those props are pretty fast once you get moving. They're just basically the design of those props just doesn't lend itself to being tested on static. So that's why I didn't include it, and I don't usually test that prop anymore. Because it always shows like very low, so you know, it might mislead people. But you know, if you want to know what a 5-inch prop would do, I think this 5030, it's a pretty good indication. So there you go. That's the test for this motor. I hope you find the data useful, and see you on the next one.